All right, I wanted to do a little bit of training on energy bill disaggregation, which is basically just briefly looking at an energy bill and having some idea of what's going on in the house. So, where are they using energy, where are they not using energy, and so forth. So, in a few seconds, I can get some kind of idea about what's going on in a house if I know a few other things. So, like if I know the blower door and if I know what kind of equipment they have, gas furnace, gas water heater, things like that. I can pretty quickly look for trends and try and understand what's going on. So I wanted to run through two different houses. One is relatively easy, and the other one it is an unholy terror. So between the two, we'll have an idea of what the spectrum might look like. So let's start with this one. So this is a 3,500 square foot house. It's 2 stories. Tricky part of this one was it has a large bedroom, like a 20 by 20 bedroom, over the garage, which is 20 by 20, give or take. And then it also has a full basement, and they had a decent sized heated space down there as well. They have a bunch of kids, 4 kids, and for this one, most of them were home. So again, understanding the occupancy and so forth is important. And when we started this project, they had a gas water heater. It's an induced draft, pretty big one, 65 or an 80 gallon. And then they had a 120,000 BTU furnace. I forget the exact blower door number on this house, but it was, say it's in the 3,000 range. It was decent, it's not great. And we cut it about in half by the time we were done. But that's not material to this discussion. So when you're looking at a bill, the first thing you want to look for is the lowest month. So looking at this, so this is kilowatt hours per month. This is an electric bill, and I zoomed in enough so you can't tell the address and so forth. But note that April's 1100, May is a little under 1100, October's 1100, November's 1000, December's 1000. So their basic usage every month is somewhere in the 1000 to 1100 kilowatt hour per month range. And so if you know that, you can look at any of the other months, and if it's a lot more, you can try and figure out what that's attributed to, particularly by time of year. So now that we know that their base is 1,000, we can take a look at what the summer months are. So I usually start with summer because we have a reasonable cooling season here, 3 months, something like that. And it's usually July, August, and September. Now, an important note here, this may say July, but check what your bill says. This bill could start on July 2nd, which means that it's actually June's bill, not July's. So it depends on the billing date. So there's all these little nuances that are a pain at first, and then you kind of quickly start looking for it. But in general, it's going to be kind of sort of close. So if you see July, it's summer. It's either June or July. It's doubtful that it will be later. So we know that it's about 1,000 kilowatt hours per month. And then you look at these months. So we're at 1450, 1400, 1450 again. So July, August, and September are the typical big cooling months. Sometimes June is, and again, this because of the billing date, this might only capture a piece of June, which is fairly likely, because our cooling season doesn't usually start till about June 15th, give or take. Okay, so that is about 400 kilowatt hours over what their normal usage is. So you look at it, you're like, okay, so it's about 400 kilowatt hours per month of cooling, which means 1,200 kilowatt hours per year. Although it's going to be more because there's going to be some in October, there's going to be some in June, and some in May. But rough numbers, 1,200, and then you'll probably round up and say 1,500 kilowatt hours a year for cooling. And depending on what your prices are, it's 13 cents here. So if we're talking 1,500, that's like $180, $190 a year for cooling. So call it round numbers, $200. When you go in true your energy use in EDS, you're going to want to true it to somewhere in the $150 to $200 per year range, depending on what you are comfortable with. and that's going to move your cooling load and true it to something pretty close to reality. And that's always interesting. Now, keep in mind, you need to ask what their set points are. If they keep their house at 78, that's not going to be a high bill. If they keep their house at 68, and that's all the more that it is, you know that house is tight, or their air conditioner's really efficient, or both, because that's not a lot of usage to create that much delta versus outdoor temperature. So again, there's all of these things you have to have in the back of your mind. But EDS does help with this because it asks at least some of these questions, so it'll true it reasonably decent, but you better ask what their set points are. Okay, so that's summer. We're looking at 400 kilowatt hours a month extra for cooling, give or take. Then you look at winter, and this one was interesting. So again, November 1000, December 1021. Although you also have to pay attention to, this is a good bill. See these A's? That is all actuals. If you get an E for an estimate, see right here, E for estimate, or C for customer, that may throw your numbers off. So you have to keep an eye out for that. But this is a good, clean energy bill. So we can trust all of these numbers. Okay, so January, look, almost 1,500. Actually, so this is January the year before, and then February at 1,400, and then January of the current year of this bill is about 1,500. So you look at these, okay, there's 400 kilowatt hours a month extra in the coldest months. And this could be lighting, maybe, if they have a whole bunch of incandescents, but this client didn't, so that's probably a space heater, is usually what that means. And sure enough, the daughter had a space heater in her bedroom, which is over the garage, and was very difficult to heat or cool, and was one of the main objectives. So again, when you know all of these pieces, you're not going to be able to figure everything out, but you can get a pretty good gut. And frankly, everything we deal in they're scientific wild ass guesses. So they're not flat out wild ass, but we're reading between the lines on a whole lot of things to try and figure out how do we reduce risk and increase odds of success. That's what we're doing the whole time. Okay, so that's the basics of this. You look for the low month. That's your baseline, and then you look for summer usage, how much is cooling driving up, and then you look for winter usage to see if there may be a space heater involved. Now, it's nice if you can get another bill. So this is a couple of years earlier. This client is crazy organized, and they presented me with like 10 years of energy bills. So I just took my pick and snapped a picture from a couple of other ones. And note that a couple of years earlier, their usage was a bit lower. So they're in the 700 or 675 kilowatt hour per month range, where they were running more like 1,000 a little bit later. So I don't know all the energy things that were driving that. I didn't really ask. I didn't get into it. It wasn't an objective. And it's not $30 a month. I don't really care. It's not a big deal. But took a look at this. And again, look at your summer. So their baseline now is about 700 kilowatt hours. Look, 1,100, 1,100, 1,300. So this is what, 500 more than base, 600 more, and the other ones are 400 more. So that 400 kilowatt hours per month for cooling, that sounds about right. So that's $50 a month, something in that ballpark. So again, if you're going to promise people in climate zones 5 or 6 that they're going to save a whole lot of money in their cooling, you're smoking crack. There isn't anything to shoot at. Most of these houses are spending $200 a year on cooling. It just isn't there. So don't promise that. And frankly, it doesn't justify anything beyond a SEER 13. It really doesn't. Where you can justify more is if you use a heat pump, so that instead of the system running 3 months a year, it's running 9, 10, 11, 12 months a year. All of a sudden, you can justify a better piece of equipment. Plus, you can justify the better comfort that will come along with that. But in general, if you're looking at just the numbers, SEER 13, that's all you should really be recommending. It really is. Okay, So again, we double checked that our baseline is down. A couple of things here. So this one has a couple of estimated bills. Take a look at December of 13. So where's that? Sorry, November of 13. So that's an E for estimated at 741. So that means that these two numbers are probably a bit wonky. And then here, with this being an estimated bill in January of 13, we don't know if that was right or not because we need to see the couple of months before. So if you get a lot of estimated bills, because this one has 4 on it, that bill, don't trust these numbers too much. That's going to be a problem. See if they have another bill from another year. That's going to be the better way to go. And then you can look at the totals. So this is 10,400 per year. And then if I back up, we're at about 15,000 per year here. So this gives you an idea of the bounds of what's going on. So your electric usage needs to come in between 10 and 15,000. That's a pretty wide variance. Most people, you're going to see maybe 1,000 a year variance. Okay, so again, this house has gas water heater and gas furnace for this bill. It's a 120,000 BTU furnace, and again, the induced draft water heater. So what you do is you again are looking for that baseline. So look at June, July, August, September. We've got 4 pretty flat months. This is a little bit tricky to read because the chart gets high enough here. But let's call this somewhere between 2 and 3 MCF, and an MCF is 10 therms, give or take. So we're looking at 20 to 30 therms per month, and that is your water heating. That's also going to contain cooking and a gas dryer. So this gives you an idea of what you're looking at for your baseline. Then you look at all the other months, and you can see what is the usage. So their high usage in January and December looks like 22 MCF, 220 therms. That's not very much. Then you can look at the annual usage here as well. And again, the baseline, let's call it 25 therms a month. So that's 300 therms a year of baseline usage. So if we take this is basically, read it as 1,200 therms instead of 120 MCF. And if 300 of that is for water heating, we know that 900 is space heating. So now that's what you want to true to, is about 900 therms. And then you need to know what your gas cost is, because with EDS, you're going to need to know that. So 900 therms, I usually figure here somewhere between 70 and 80 cents per therm, all in, because the meter fee here is very high. It's $30 a month, and then the gas itself is very cheap. It's 35 cents a therm, but the meter fee and then the other crap that they add on as part of the bill pumps it up to somewhere between 70 and 80, depending. If they don't use very much, they're going to be on the high side. If they use a lot, it dilutes the meter fee and it's not as much. So you want to have an idea. And so 900 therms times, let's say 70 cents a therm, whatever's the $630. So their heating cost for the year is going to be between $600 and $700. And so in EDS, when you go look at that, you need to true it to that. But you don't true it first. You go and you change all your R values and you enter in your blower door, and then you go back to the top, because now the house is set up the way that the house really is. And then you go back to the top and you play with your energy usage, the energy cost to get there. And then whatever you predict from there is much more likely to be good. So very important point. Okay. So 900 therms, we kind of figured all this out. So this house is relatively simple to disaggregate. So it was pretty easy to see what the baselines are and to look for space heaters in the electric bills and about what they're paying for their heating every year. So hopefully that makes sense. Do the baseline and then look for the pieces that you can chunk out. Now this next one, this house is a problem. So this is an all electric house. So surprise, surprise, they are harder to disaggregate because everything is in one bill. And worse, with the heat pump, if the thing is not commissioned well and it's leaning way too hard on resistance than it is on the heat pump, now you really have no idea what's going on. And that's really frustrating. So that's where you really need to know your blower door. You need to know your R values. You need to be able to figure out what that house actually is, and then get to where you actually trust your model, because this usage is going to be a pain to figure out. So let's take a look at this house. This is a 4,200 square foot ranch. It's on a slab. It's all one level. It has 2 heat pumps running it, and all the ductwork is in the slab. This house was just changed to 2 furnaces and 2 air conditioners December of 19, so right about 6 months ago from now, I guess pushing 7. So you take a look, and you want to look for the baseline on this, and the baseline's not very easy to see. So here's just under a 2,000. Here's a 1650, so I'm going to look at that, and then you double check 1653, October of 19. That's an actual, and there's a couple of actuals before, which means that number's good. So that's their baseline then, is 1650, something like that. But this is a really noisy bill, and it's difficult to figure out. And then you want to look for your high heating bill at 6550. This is nuts. My old house, before we started electrifying a few things, the water heater and my electric car and things like that, we were using about 7,000 kilowatt hours a year. So this house in 1 month used what my old house used all year. That's wild. And typically our electric houses are seeing somewhere between 1,500 and 2,500 kilowatt hours a month in the colder months to keep them warm. So to see something that high, even though it's a larger house, I'm like, something's going on. I'm betting that those thermostats sucked, or they weren't set up right, and that thing was banging resistance way more than it ever should have. So something was going on. But look at the total usage down here too. 40,000 kilowatt hours per month. That's a ton. Very seldom do I see a bill that breaks 20,000 per month. And at 13 cents a kilowatt hour, that's pushing $5,000 a year. That's a really expensive house to run. Okay, so this is that same house, but it is the most recent bill. And in December, the heat pump was changed out. So here's an actual, and what was it, 3,600. So that's when the winter's really getting wound up here. We know that this changed here. So this 2,700 here, this is what their house was using. This is not HVAC. Because they switched to basically a Navian. It's an on-demand water heater and 2 furnaces, and the air conditioners are air conditioners, not heat pumps. So we know that all of that gas usage went away for January. So now we can look for their baseline usage, and we are so the lowest one here is 1,000 kilowatt hours for the month, and that's pretty impressive because this is March, so that involved some quarantine. So there were a lot of people home and doing stuff. Now, what you can do is most resistance electric water heaters are going to use between 500 and 700 kilowatt hours per month. Depends on the size of the household. Might be 300 if it's 2 people. But their boys were home a fair amount of the time, so there's some in here. So let's back up. So here's 1,041. And their low month was 1,650. So there's about 600 kilowatt hours difference between their house as all electric on the lowest month and their house now not electric in the lowest month. And that makes sense that that would be water heat. Doesn't mean for sure that it is, but it adds up. Basically, you're constantly applying a sniff test. Does it smell right? And if it smells right, you can move on, because you can find all sorts of stuff. I had one all-electric client complaining about electric bills, and there was 500 kilowatt hours that I couldn't figure out what it was just from doing this quick aggregation that I'm showing you. And yeah, it was grow lights. So Life is interesting. You can find all kinds of stuff through bill disaggregation. That one still makes me chuckle quite a bit. Okay, so 1,000 kWh a month is their baseline now. So anything beyond 1,000, or let's call it 1,100, something like that, that is getting into cooling. Now, this house, I had an unusual piece of information because they had Infinity carrier Infinity controls, and I'm very familiar with that stat, so I went and looked at the usage. And even though it was only 80 degrees the day before, the two systems had used 120 kilowatt hours between the two of them. It's like, holy cow, that's a crap ton. So we had to figure out what was going on. Turned out to be leaky returns that were pulling from the attic that was driving that up. But what you can also do, remember we go look at the summer bills. So even though this is the old system, it's two air conditioners, you're going to have some idea of what's going on. So they were running, so 1,600 was their baseline, 1,700. So they're pushing 1,000 kilowatt hours a month for cooling. That's a lot. That's a whole lot for our climate, and that jived with 120 kilowatt hours that I saw for that one day. Okay, so there's a lot of cooling loads. Something here is going on, which means you need to true your cooling cost up when we get there. So let's say it's probably going to be somewhere between 3,000 and 4,000 kilowatt hours. So let's say 4,000 and then times 1.3. It's like $450 for the year for cooling. That's a lot for our climate, even for a bigger house like this. So that gives me an idea of what's going on. And like, okay, so again, what we're trying to do is disaggregate to figure out what do you need to put into EDS for costs for HVAC. Now this house, it was also kind of nice that they had some pretty clean gas bills. So this furnace system went in mid-December, and then January, February are our two coldest months. And this is pretty low usage for a house this size. So overall, we're looking at it's 700 therms between these 4.5 months. So I'm betting that this house is going to use something like 1,000 therms a year, 1,100 therms a year. And I have a basic rule here. Doesn't mean that it's going to apply everywhere, but as you watch enough of these bills, you'll start creating these heuristics in your mind too. If the house uses the same number of therms as it has square feet, the house is an utter pig. It's an F minus. So this is a 4,200 square foot house. If it used 4,200 therms, that is hideous. Really, really bad. When you get to a 0.5 to 1, so if a 4,200 square foot house was using 2,100 therms, that's still pretty bad because 2,000 therms is a lot of gas. It's my old 1835 barn used 1,500 to 2,000 therms of gas a year, and I very seldom see a house over 3,000, even when it's a bigger, older brick house in the near outskirts of Cleveland. So 0.5 to 1, 2,100 therms would be bad. When you get down to a quarter to 1, so this house using 1,000 or 1,100 therms, that's pretty good. That tells me that the house is fairly tight, and you'll oftentimes find that house is going to be in, say, the 700 to 1,000 square feet per ton ballpark for heating. And that was kind of where we got the house to. So I'll record that in another video where I had to true this exact house, and it was a nightmare. This was really hard, and this was very, very strange that the cooling load and the heating load were almost identical on this house, and I haven't seen that before, and I don't know when I will ever see it again, because it's almost always 2 to 1 heating to cooling here. So if you've got a 20,000 BTU cooling load in Cleveland, you probably have a 40,000 BTU heating load. So that was very unusual. But by looking at their bills, I could disaggregate this and come in with some reasonable confidence as to what size equipment they need. but I also needed a blower door. I really needed to figure out that they had those leaky returns. There are all of these other things that go in that the comfort consult, you may not collect everything you need, but if you can get 80% of the information that you need to size something well, you are ahead of all but 0.1% of the rest of the industry. Nobody does this stuff. So it's really important to figure this stuff out. So anyway, when I trued this, and I'll record that next, I was truing it to 1,000 therms a year. So I was figuring that they were going to spend $600 or $700 a year for heating, because again, 70 or 80 cents per therm here. And then they were using 4,000 kilowatt hours a year for cooling, somewhere in that ballpark. So I was truing it to something like $450 for cooling cost for the year. And so those really helped me figure this out. So that's disaggregation. Hopefully that makes some kind of sense. You go look for your baselines, and then you go look for your outliers, and then you try to understand what your total heating usage is and what your total cooling usage is, because you need those to run a really good load calc. Hope that's helpful. See you in the next one.